All right, so I want to do a little bit of review that you can always fall back on just in case, and also so we can get into talking about calculus much sooner. So most of the stuff I expect you to know. There might be a couple of like, new things here and there. Anything that I feel is like new and students don't know, I'll go over again in class. So everything that I do has kind of like an understanding sheet at first, basically, so you can kind of get the main ideas. If you can't understand the main ideas, if you don't understand these few things, you really don't understand that packet of notes, right? So I'm not going to define words, but these are kind of like the words and language that you should be using from the module. And if there's any kind of like important theories or I guess formulas, like I'm going to stick that stuff there. So we're not going to do activity one. I mean, feel free to get a friend and talk about this stuff, but I'm going to jump in and make these kind of quick page or two videos. So I'm not like, spending 15 minutes of your life watching a video. So in calculus, one of the most important things is working with functions. You've been working with functions since pre-algebra, but I would gather that most people can't actually define what a function is. So we kind of like use these little like it's a machine where you put something in and something pops out, which kind of like works, I guess. But for me, the definition of a function that I like is simply a function is a rule that tells you what to do with an input value, right? I give you some value, you manipulate it in some way, and you have a new product. Well, that's a function, right? So you can also have a rule where I give you something, you look at it like, oh, that's cool, give it right back and nothing changes. That'd also be a function. But as long as you always know what to do with something once I give it to you, well, now we're talking about functions. So a couple of things in terms of the language of functions. So anything that I can actually input into a function is what we call the domain of the function, right? It's the allowable values of x. And anything that we can get out of our function, anything that results from our function, well, that's going to be called, whoops, that's not a highlighter. That's going to be called the range of the function. Again, I expect most students have seen this language before. Right, so when we kind of like first deal with functions, right, the way that we kind of like work with functions is that we're kind of given a test, right? We say that it's anything that passes a vertical line test. So now technically, if we're, if you're going to go further on in math, right, there are different coordinate systems that exist, right? So when we talk about the vertical line test, we're talking about whether or not a function is a function, the XY plane. Right? So if I were to draw a vertical line here, any vertical line that I draw is going to hit the function at most one time. It could also hit its never, right? This would be a function. So this is a function. Whereas it's a technically a function XY plane, right? Whereas if I draw a vertical line there, right, notice that I'm hitting my circle, in this case, more than once vertically. So this value of X right there, that value in the domain, is kind of popping out either that value of Y or that value of Y. So we'd say this is not a function in the XY plane. Anything we talk about in this class can be in the XY plane. But again, if you're kind of going on further in math or you're anticipating a math minor or something like that, yeah, it's kind of good to know that there are different systems that exist. All right, so other things that kind of like pop up, something we've heard very, very often since first grade, right? PEMDAS, right? So the order of operations, but same kind of thing, something we've been working with for a really, really long time. Many students struggle defining what an operation is. So basically, an operation is just a function. So operations are functions. So when we talk about addition, addition is a function. When we talk about multiplication, multiplication is a function. When we talk about taking the square root or taking a logarithm of something, all of those things are functions. So what operations are is um, let's say a visual representation of what to do, what to do with an input value, right? So kind of this idea is if I say, I'm going to define this square root operation, right? So this operation right there, So that kind of like square root. So what does that symbol tell me to do? That symbol is the visual representation of what I'm going to do with 16. I'm going to square root that thing. I'm going to get 4 back out of it, or -4 if I actually took the square root myself, like x squared equals 16. All right, so here, if we're also kind of looking at this language, this 16, this value there, this domain value, also called the argument when it's being applied to an operation, would be 16, and then that value of 4 would be some value in the range of this function. So when we kind of think about this relationship between functions and operations, if I have an actual f of x function like the square root of x, and I plug in f of 16, I'm getting the exact same question. I'm saying, well, I'm going to throw in a 16 wherever I had an x, right? This is my input, my domain. That's where it gets replaced with, right? That's the input value in my function. And, well, we have some value. Now, if I want to take all of the possible values that this operation of square rooting could do and graph that in an xy plane, that's where these graphs of functions exist. So for example, if I wanted to graph f of x equals the square root of x, I can imagine what would happen if I were to put, okay, the square root of 0, square root of 1, square root of 4, square root of 9, square root of 25, and get these nice, easy values that I could take square roots of. But then also there's square root of 10, there's square root of 13, there's square root of pi, there's square root of 1/7, right? All of these possible values of x in the domain of the function. So these are values of x. Anything that's a non-negative number, we could take the square root of. It might not be a quote unquote nice number, but we can still take the square root of it. If we were to connect all of those values with some sort of graph, this is what the square root function would look like, right? So this is like our f of x equals the root of x. If I say, hey, here's a 16, that might be the value of 4, right? We can see that everything that I plugged into my function is giving us some value out on the graph. So for now, that is the most important thing, right? This function is just an operation. And if I have an f of 16 and it equals 4, it's really just telling me that I have some specific points on the graph of the function itself. So I'm going to pause there. It'd be, again, review, do whatever you need to, right? So if you are unsure with functions, we can kind of plug these values in and calculate them. I'll do that calculation in a separate video.